Notes for 9.3 and 9.5. We're doing geometric sequences and series. So remember back last time, arithmetic meant we added. Geometric means we're going to multiply. So number 1 says find the common ratio. Common ratio, we're going to just call that R. All right, R for ratio. And all that means is what are we multiplying by? So times, times, times. It looks like we're multiplying by -3. Times -3, times -3, times -3. So that's it. That's the common ratio. R equals -3. Find the 3 terms in the sequence after the last one given. This is geometric. Geometric means we're going to multiply. That means there's a common ratio. I think the hard part for this question is just figure out what we're multiplying by. And it looks like we are times -2. So each term, the next term, times -2, times -2, times -2. We look at this term of 8, times -2 is -16, times -2 is +32, times -2 is -64. That's your next 3 terms. Next one. We might need a calculator, so I'm going to go ahead and get that fired up. Again, it's geometric, so we can see what's happening. Can you see what's happening? Times something, times something, times something. I suppose if you couldn't see it, what you can do is go backwards and divide. That thing's still getting warmed up here. So if I do like 128 divided by 32. I don't know what this thing is. I wish it would go away. It's 4, but you could probably see that anyway. Times 4. Times 4. So next terms, I'm going to multiply by 4. See if I can. There we go. So 128 times 4 is 512. And then times 4 is 2048. And then times 4, those are our next terms. 512, 2048, and 8192. 512, 2048, and what was it? 8192. Okay, next 3 terms in the sequence. Next, we want to find the recursive formula. So remember from last time when we talked about recursive, we talked about previous terms. So for a recursive formula, if we wanted to find the nth term recursively in a geometric sequence, we would take that previous term times the ratio. But we also need the first term. So a recursive definition is weird because you've got 2 steps. You've got this formula that seems important, and then A1 equals the first number, whatever that is. So don't forget this second part. That's going to be important for our recursive formula. So we've got a couple of things going on here. Number 1, let's find R. R is what we're multiplying by. Since this is times -3, we know that R equals -3. We also need to know the first term. The first term is just this 3 right here. That's A1. And so our recursive formula is going to say AN equals AN minus 1, that's the previous term, times R is -3. And we've also got the first term, A1 equals 3. There's your recursive formula. Don't forget both parts. Next one, same deal. It looks like we're just multiplying by 3 to get to the next term. So we see R equals 3. This is the first term. A1 is 1. So your recursive formula, an equals an minus 1 times 3, and a1 equals 1. Recursive. Recursive sequence uses previous terms. Now we need the explicit. So again, recall from last time, when we talk about explicit, we just want to use in. We don't want to use previous terms. We want to use in. And so the explicit formula for a geometric looks like this. Sometimes we call it the nth term formula. An equals a1 times r to the n minus 1 power. So we need that formula. Every time we see explicit on a geometric, we're going to use that formula. So what do we need? Well, we need a1, and we can see a1 is 3, but we also need to know r, and r is just how we get to the next term, next term, next term. It looks like it's times 4, times 4, times 4, times 4, times 4. So r equals 4. We don't need n because n is just going to be a variable in our equation. So our explicit formula for the nth term, an, equals a1, that was 3, times r, which was 4, to the n minus 1 power. I know that gets a little bit confusing with an n minus 1 in the exponent, but make sure that n minus 1 is all small. All of that n minus 1 is inside the exponent. It's all superscript. Number 13. Obviously, the first term is 3. A1 is 3. You've got to be able to figure out how to get to that next term. So again, if you couldn't just see it, you could always like start with a number and work backwards. Negative 15 divided by 3 is negative 5. So you should be able to see at some point. If you can't tell that r is negative 5, then divide. Divide a number on the right by a number on the left to the number right before it. But you can see r equals negative 5 because it's times negative 5 times negative 5 times negative 5. So we use that explicit formula equation to find the nth term. It's going to be 3 because that's the first term, times r, which is negative 5. Here's something you need to pay attention to. If it's a negative number, put it in parentheses. If it's a negative number, put it in parentheses to the n minus 1. If you don't put a negative number in parentheses, it's not going to work right with your exponent, so be very careful with that. Next, number 15, find the nth term. We're talking about the nth term here. And so they're basically asking you to use the explicit formula, okay? The difference is, though, we know n. N in this problem is 12. So what they're saying is find the 12th term. Find the 12th term. Remember what the explicit formula was. It was an equals a1 times r to the n minus 1. That was our formula from the last problem. That was the explicit formula, or the nth term formula. So again, we need a1. A1 is negative 2. So that's a1. Times we need r. So r is just how we get from term to term. Times negative 2, times negative 2, times negative 2, r equals negative 2. So put that negative 2 inside parentheses because it's going to have to hold off that exponent. Now, the difference here between last time, or from last time, is last time we didn't care what n was. We just left it as an n for our formula. But this time we know n is 12. So that exponent is going to be 12 minus 1, But if you know what you're doing, you're just going to call that 11. The one right before it. All right. So our exponent is going to actually be 11. We will have -2 times -2 in parentheses to the 11th power. You definitely want a calculator for this, but you also definitely want to be able to know how to use your calculator for this. -2 times parentheses -2, and again, I can't stress this enough. If you don't put the -2 in parentheses, you might not get the right answer. Depends on how your calculator handles it, and a lot of them don't handle it right. So -2 times -2 to the 11th power, 4,096. And so, another way of doing this problem would be, this is the first term, second term, third term, fourth term, find the 5th, 6th, 7th, 8th, 9th, 10th, 11th. So times -2 times -2 times -2 on your calculator. I suppose you could do it that way. The 11th term there is 4096. Or wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sorry, the 12th term. That's A12. A12 equals 4096. Why I messed that up and said 11th term is because you'd be multiplying 11 times. Multiplying times -2 11 times. That's how you get the 12th term. Number 17, we want to find the 11th term. So again, remember the nth term formula. And since n is 11, we're finding the 11th term, but we're actually going to use the exponent of 10. So we need the first term, that's 4, times the r value. R value looks to be 3. And since we're finding the 11th term, 11 minus 1 is 10. That's your exponent. Now, I don't need my 3 inside parentheses here because I don't have to deal with the negative, but you can put them in parentheses if you want. 4 times 3 to the 10th power, 236,196. Next one's a story problem, and I know how hard it is to do story problems sometimes, but let's read it. In your first week of training, you can run 0.25 miles without stopping. You double that amount each week after that. During which week will you reach your goal of being able to run a full marathon, 26.2 miles without stopping? Notice we start and we can run 0.25 miles. Or you can, but it's kind of important that you're doubling that each week. All right, so the next week, I think the easiest way to do this problem is just to list it out. A sequence is a list, and the next number in the list, if you double that, is 0.5. And then the next number in that list is 1. And then double it, you get 2. And then double it, you get 4. Notice when we can stop, we have to be able to run 26.2 miles. So just keep going. Double it, and that's 8. Double it, and that's 16. Double it, and that's 32. Okay, now we're talking. Now we can run our 26.2 mile marathon. So all we have to do is say, which week is that? That's week 1, 2, 3, 4, 5, 6, 7, 8. The answer is week 8. Now that's not the only way of doing the problem. Another way of doing the problem is using that nth term formula, but I think this is way easier. We can always just list out the numbers. Number 21 says evaluate the related series. So you've got to remember, when they say series, remember last time, they're talking about a sum. Series means sum. And so all I have to do is add these numbers together. 60. That's all I did was add them up. Series, add them up. Sum, this sum of those numbers is 60. Okay? Now, the thing is, you won't always have all of the numbers, so you won't always be able to add them up. Case in point, remember the Greek symbol sigma. Sigma is the Greek letter for S, and S means sum. So remember that from last time. Sigma, they're talking about sum. Well, we've got a new formula for a sum of a geometric series. And I think this is the hardest formula. The geometric series looks like this. S n equals A1 times the quantity, 1 minus r to the nth power, all over 1 minus r. And if you use a calculator, you're probably going to need parentheses around this. So we might as well put parentheses around that. Okay? That's a pretty tough formula, but let's look at this. When we look at our sigma statement, number 23, a couple of things you should be able to notice. First of all, if we start at 1 and go to 9, you should be able to see that n equals 9. Now, it's not always the case that n is just that top number. If we started at something other than 1, it wouldn't be that top number. But since we're going from 1 to 9, you can just count 1, 2, 3, 4, 5, 6, 7, 8, 9. There will be 9 numbers. Your r value is just whatever this number is right here. R equals 3. That's your base on your exponential. So that's a base 3, whatever that number is 3. Now A1 is not as obvious. A1 is what you get when you plug in this first number. Remember from last time. Last time we had to do A1 and AN. This time we just need A1. A1 is what you get when you plug in this first number. So 3 to the 1 minus 1. That's 3 to the 0. Remember, anything to the 0 power. You should know this. 3 to the 0 is 1. Anything to the 0 power is 1. So we can see A1 is 1. We want to find the sum of those 9 terms. So Sn, there are 9 terms. That's what you'd get if you plugged in 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to be A1, which was 1, times 1 minus the r value was 3, to the nth power, and n in this case is 9, all over 1 minus r is 3. So again, I probably want a calculator just because I don't want to have to do 3 to the 9th. 1 minus 3 is negative 2, but on the top you'd have 1 times the quantity, 1 minus 3 to the 9th power, and then you divide by, and I want to use parentheses here, 1 minus 3. If you want to just type in negative 2 there, that's fine. But I get 9,841. So you can either say Sn or S9 is 9841. Now, the other way of doing this problem is not very fun, but you'd plug in 1 and you'd get 1. And then you'd plug in 2 and you'd get 3. And you'd plug in 3 and that's going to be 9. And you'd plug in 4 and that's going to be 27. And you'd plug in 5 and that's 3 to the 4th, that's 81. And you'd plug in 6 and that's 3 to the 5th, and I think that's 243. And you plug in, what was that? 1, 2, 3, 4, 5, 6. And you plug in 7 and you plug in 8 and you plug in 9 and you add those things up. I don't want to have to do that. I don't have to do that because I have this formula. So then we look at number 25. Now again, you're going to need to know n. N is 8. R is 5. And A1 is what you get when you plug this number in. So 5 to the 1 minus 1, That's 5 to the 0, and that's 1. It will not always be the case. It will not always be the case that that's 1, but it is in this case. So again, your formula is this. That's the sum of a geometric series. So we want the sum of 8 terms, because n is 8. That's going to equal a1 was 1, times 1 minus r was 5, to the nth power, n was 8, over 1 minus 5. So the only thing I might recommend you do without a calculator is 1 minus 5. If you plug that in on the calculator, you're definitely going to need parentheses there, so be very careful. You've got 1 times 1 minus 5 to the 8th power, close parentheses, divide by, open parentheses, 1 minus 5, or negative 4 if you like. That's 97,656. The sum of the first 8 terms is 97,656. Right, 27 looks more complicated, but it's still basically the same idea. We can see n is 9. Okay, r is negative 3, not the 2, not 2 times negative 3, it's negative 3, and you can tell because it's the base on the exponential. Whatever carries the exponent, whatever holds up the exponent, that's your r value. That's what's getting multiplied times, 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 times. A1 is what you would get if you plugged in 1, or this number right here. So we have 2 times negative 3 to the 1 minus 1. That's 2 times negative 3 to the 0. And negative 3 to the 0 is 1, but we have to multiply it by 2, so 2 times 1 is 2. A1 is 2. That's the first term. That's the first term. So S9 is, okay, remember the formula, Sn equals A1 times 1 minus r to the n over 1 minus r. So S9 is A1, and that's 2, times 1 minus r is negative 3, so I'm going to put that in parentheses because that negative 3 has to get raised to a power. So I'm not going to say minus minus is plus plus. I'm not going to say that because you're going to have negative 3 to the 9th power here. All over 1 minus negative 3. Okay, lots going on. That's why I would highly recommend you use a calculator with good parentheses. 2 times 1 minus, I'm using parentheses for my negative 3. Take that negative 3 to the 9th power and close your top parentheses. Now I'm going to divide by the bottom, which was 1 minus parentheses negative 3. Close the negative 3 and then close the bottom. Now, of course, you could probably do the bottom, 1 minus negative 3. That one's going to be minus minus is plus plus. That's 1 minus 3 is 4. So if you want to simplify the bottom and say divide by 4, that's fine. Otherwise, just type the whole thing in. You get 9842. 9842. The sum of 9 terms, the first 9 terms, is 9842. Number 29 looks like it's going to be harder because you've got an infinite series. We're adding up, check it out, we're adding up an infinite number of numbers. This is kind of weird because we're going to be adding up an infinite number of numbers, and you might think, well, that's impossible. But it's not because we've got a formula for it, okay? The infinite geometric series has a formula that looks like this. The sum of an infinite number of terms equals A1 over 1 minus R. What's ironic here is you're adding up an infinite number of numbers, but the formula is actually easier than the last one. Okay, so R is just the power, the number that's holding up the exponent. R is 1/3. For an infinite series, this R number will always be a fraction or a decimal number between 0 and 1. Okay, or actually between -1 and 1, I guess. But you've got to have a fraction or a number smaller than 1, basically. All right. So what? We've got R. We need A1. A1 is what you get when you plug in this number right here. So -4 times 1/3 to the 1 minus 1. That's -4 times 1/3 to the 0, but 1/3 to the 0 is just 1. You're going to get -4. A1 is -4. So for my infinite series, the sum of an infinite number of terms is going to be -4 divided by 1 minus 1/3. Okay, now again, you should probably put parentheses around this if you're just going to type it in on a calculator. If you don't put parentheses around that and you type it in, you're probably not going to get the right answer. So be very careful there. So we have -4 divided by quantity 1 minus, I'm going to go ahead and put this in parentheses as well, but it doesn't really matter for this one. And close that bottom. 1 minus 1/3. -6. Seems kind of weird that you could add up an infinite number of numbers and the total is -6. The reason for that is because basically this is a calculus topic, but as this number gets bigger and bigger and bigger and bigger and bigger towards infinity, then this fraction, once you multiply it, gets smaller and smaller and smaller and smaller and smaller. And so when this number is really, 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 really big, this quantity right here is really, 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 really small, like basically 0. So you just keep adding basically 0 on, and that's why it ends up being -6. So then the next one, R is just this fraction right here, 2/5, and A1 is what we get when we plug in this number. 4 times 2/5 to the 1 minus 1. That's going to be 4. Because that's going to be to the 0 power. That's going to be 1. 4 times 1 is 4. My infinite sum formula is A1 over 1 minus R. So in this case, I'm going to have 4 over 1 minus 2/5. 4 over 1 minus 2/5. Now again, use parentheses and just type it in. That's what I would do. 4 divided by parentheses 1 minus 2/5. That's about 6.67. That's 6 2/3. Or 18/20. That's 20 over 3. So you've got several different ways of writing it. I'm not sure I care which. Okay. Last one, 33. Again, this looks like it's going to be kind of tough, but here's R. R equals 0.8. And you need A1. A1 is what you get when you plug in this number. 3.3 times 0.8 to the 1 minus 1. Well, that's just going to cancel out because that's 1. So A1 is just going to equal 3.3. It's not necessarily always going to be that number, but just do what it says. We want the infinite sum. We're going to take the first term, 3.3, divided by 1 minus R, which is 0.8. If you want to do that in your head, 1 minus 0.8 is 0.2. So you're taking 3.3 divided by 0.2. That's probably the easiest thing to type in. But of course, you could also divide by 1 minus 0.8, assuming you put it in parentheses. Okay? One thing you don't want to do, check it out if I don't use parentheses. 3.3 divided by 1 minus 0.8, that gives me the wrong answer. Okay? That's the wrong answer. Do not do it that way. You must use parentheses. And if you use parentheses there, you're going to get 16.5. The infinite sum is 16.5. An infinite number of numbers added together adds up to 16.5. Kind of cool.